All right. Thank you. And hello, everyone. I wish I was on site with you for this great conference, but fortunately, I will present this talk remotely from Tel Aviv. So today's talk is about minimum viable security. But before that, let's start with a small intro. Basically, let's imagine that your family is going on a trip to Paris, and they're in a rush, and so they're packing their suitcase and everything, and they're rushing to the airport to not miss the flight. And suddenly, in the flight, they just figure out that they forgot something very valuable, and it's you. And if you think that this is something that you know, and that's a story that you've heard before. They actually made a movie about it, and it's called Home Alone. Now, why I'm telling you this story? Basically, if you're thinking what Kevin in his small apartment, his small house, did in the Christmas Eve in order to try to protect his house from burglars, well, basically, he tried to think of ways he could protect his home by just adding a few security tricks. A few traps that would prevent burglars to enter into his house. He didn't have time, he didn't have money to hire security guards. He tried to do the minimum stuff in order to slow down the burglars. At the end, the burglars enter into the house, and so for security, you may think that everything that you add in order to protect your application will actually stop the attackers, but the question is not whether you'll be able to stop them, is when the attack will happen and whether you'll be able to see that in a timely manner in order to close the gap. So what he did in the movie is basically what I would call minimum viable security, which is trying to find the minimum things, the minimum critical controls, if you can think about it, in order to protect his house. And this is what I want to talk with you about today, how to apply this principle of minimum viable security to microservices. I'm David Melamed. I'm the co-founder and CTO at JIT. JIT is a startup that provides continuous security platform for developers, which means that basically want to help the engineering organization to protect the application that they're building, and in a way that they don't rely on an external security team anymore. I'm a tech addict. I like automation. I really like security. I've been in the security field for a couple of years, and I'm really glad to be able to present at this conference, thanking the organizers for having me here. Basically, if you're going back to the burglars, these are the two attackers, the wet bandits in the movie. And if you think about it, what Kevin did when he thought about how to protect his house, he tried to think of a way to map the whole house in order to prepare some plan. You could call that, this is the battle plan. You can call that for your application, the security plan. And the way he thought about that is basically try to map the different entry points into his house to protect from the burglars. And so he tried to map all the entry points, and for each one, try to think of a way he could protect it using some very cheap tricks. Okay. Now, when you're thinking about your application, you can probably do something very similar. The first thing you want to do, and this is also what Kevin did, is try to find the places where your application is vulnerable because it has some external exposure. So trying to think of protecting first your parameters. And so if you're thinking of your parameters and the way you can enter into your application, basically, if you have an application that is hosted on a public cloud in Kubernetes, well, you have multiple entry points into your environment. First of all, you have your code and your CI/CD pipeline, and this is the way you're deploying your application to the cloud. Second, you have in your public provider, you have user access. All your users that are accessing your, let's say, AWS account, for example. You have all your public resources that are available in your cloud, your public IPs, your buckets, a lot of resources that could be used and that are vulnerable if they're not protected correctly, or if there's some misconfiguration. And at the end, you have all the third parties that are connecting to your application, to your environment. It could be some add-on that you're installing. It could be some services, some SaaS services that you use in order to get some additional visibility into your environment. So you have multiple ways that attackers can leverage those entry points and make your whole application vulnerable. So what can you do to protect your perimeter? Well, basically, there is a lot of controls that you can apply to your environment and to your perimeter in order to protect them. First of all, if you think of your CI/CD pipeline, well, basically, what you want to do there is to apply the least privilege principle. So, for example, if you're using some token in your CI/CD pipeline in order to deploy your application, make sure that you're not having too much privilege. And for example, that you cannot create a lot of different resources in your cloud, and that you're only limiting the access of your token to the things that you really need in order to deploy your application. Second, if you're thinking of your remote access to your cloud, you want definitely to have also here the less privilege in order to differentiate between the admin access and your regular user access. And make sure that, for example, I don't know, your developers will only have read-only access to your production environment, and they only use the admin access or the privileged access for anything that is admin related. Also, of course, you want to make sure that the access to the account is protected using MFA, but that's also something that is really basic. Same thing for the third-party services. You want to make sure that you have MFA for all the services that are supporting it, of course, and maybe that's one of the criteria that you want to consider when you're picking those SaaS services, and you want to review the scope of the access that you're granting to your application. And finally, for everything that is public access, public resources, there are two types of control that you can use in order to make sure that there's no misconfiguration. For example, there are other tools, and we'll talk about them. You also want to check pen testing to ensure that your application doesn't have any known vulnerabilities. So that's for your perimeter. And going back to Kevin, it actually did quite some tricks in order to protect his house from the burglars using very innovative controls, let's put it like that. If you're thinking about your application itself, well, there's also a lot of different things that you want to think about inside your cloud providers. So, for example, you want to take a look at your traffic and make sure that it's encrypted. The secrets is also available, and you want to make sure that there is no leak there, that the secrets are safe. Access to services between the different parts of your application and your microservices is also something that you want to take into account. The libraries, and we'll talk about that, are something that is also part of the basic stuff that you want to check. And there are two other type of important topics that you want to tackle. One is having sure that you have an incident policy, an incident plan in case something happened and there's some incident happening, security incident happening to your environment. And second is disaster recovery, to make sure that your business can go on. And so these are the different aspects of the critical events or critical parts of what you want to check into your environment. And for each one of them, you have different controls that you can implement in order to protect your application. For the traffic, you make sure that all the traffic is encrypted. You want to use a secret manager. Ensure that you're using less privileged access for the different access between your microservices. For the incident, you want to make sure that you have some logging in place so that you can review what's happening. And the logging should be both done in terms of your infrastructure, but also in terms of your application, in order to make sure that any admin activities inside your application is logged. For libraries, you want to do some dependency check. And at the end, for the disaster recovery, make sure you're using some backup, and you have you're checking that and only configuring the backup for database, for example, for your data. These are examples of what Kevin did actually in the house in order to protect it once the burglar were in. And so if you're thinking like, how would look the critical controls, the minimum security controls for your classic cloud application, basically this is kind of a big picture of the different type of controls. Some are more about the binary, some about the data, and these are the different things that I believe should be critical, and you should definitely consider adding all of them when you're building your application. And so we talk about all the different controls for briefly, and I want to now take a few of them into some deep dive and give you an example of some code that you can use so that you can really easily implement those basic controls for your application. So for that, I would like to take a demo. And for the demo, I built a really simple microservice that is Python-based. It's basically a fast API application. So fast API is the framework that I used in order to host the API. And the purpose of this application is to display some movies information. For the database systems, I use SQLite, just a very, very simple database, because the importance here, not the database, but more the controls that you can add really easily to your application. I'm using GitHub to host the code, and GitHub Actions as the CI/CD pipeline. And the goal here is to show you how to add 7 different tools that are part of this MVS, this minimum viable security, into the CI pipeline. And what I will show you right now is actually available in the public repo. I will open this. I think it's already opened. So this is the URL of the repo and the application. So you can definitely play with it, fork it, and change everything there if you want to replicate this for your own application. So what I want to show you is the different types of tools that you can use, and all of them are open source, so you can freely use them. And this is merely an example of what you can do really in a very simple manner from day one when you're creating a new application and when you're creating a new microservice that is at the end deploying your Kubernetes server. So first of all, you want to ensure that your code doesn't have any vulnerability. And for that, one of the most basic controls that you can use is a SAST tool that will check for static application. And for that, here I'm using Bandit, which is an open source linter for Python that includes already 35 rules for detecting vulnerabilities. For the secrets, I'm using a great project by Zachary Rice. It's called GitLeaks. It's based on regexes for a lot of well-known secret patterns like GitHub Personal Access Token or Slack Token, AWS Keys. There are a lot of built-in regexes inside the inside this tool. And on top of that, you can also define your own rules and create your. There is some generic API key that you can customize in order to look for generic secrets, adding some filter based on the entropy. And one of the advantages, it's also checking all your Git history. So even if you removed a secret by just deleting it from your Git repo, it still can find it in the GitHub in the Git history, unless you actually rebase your history. So that's great because some developers may think that only by deleting the secret it's enough, but sometimes it still lies in the history. So that's a great tool also that I want to demonstrate how it's easily to integrate into your CI/CD pipeline. The next tool is the dependency check from the OWASP. It's the OWASP project. Everyone knows about it. It detects publicly disclosed vulnerability and based on CVEs in the NVD database. And it's also one of the must-have tool in order to have some hygiene in your libraries and making sure that you don't deploy your application with some vulnerable libraries. For infrastructure, there's a very nice tool, open source tool by Checkmarx called Kix. It has a lot of built-in rules. The rules are that are written in Rego. Rego is a policy language that is mainly leveraged by Open Policy Agent, which is not another open source tool. And there are a lot of different tools for a lot of different languages. So, for example, it supports CloudFormation, Terraform, Ansible, a lot of different languages that are used to build infrastructure. Helmchart, of course. And it's really great to find misconfiguration in your infrastructure as code. And you can also filter your vulnerabilities or your misconfigurations by severity, and only making sure that you're handling the most critical ones. The next tool we'll use here is OWASP Zap. So the web application scanner. It's great because it can be used in both modes, the web application mode and the open API mode. So the API mode using Swagger file, and this is what we'll show here also. And at the end, because we're dealing here with containers, you also want to make sure that your base image is clean and is not vulnerable. And for that, we use a great tool called Trivi, and it's an open source tool that is developed by Aqua, and also a great tool to have in your tool belts that can be integrated in your CI/CD very easily. And I'll show you that in a moment. And at the end, we talked about how it's required to ensure that you have MFA enabled for all your third parties. And so, for example, you want to make sure that your GitHub account is secure and you have MFA for all your different users. So for that, I didn't find any open source tools, so I built one myself. It's actually a few lines of Node.js in order to leverage the GitHub API to ensure that there's no users in the organization that don't have MFA enabled. So, kind of recap of the different tools that I described here. You have Bandit, Gitleaks, Kix, Dependency Check, Trivi, Zap, and a custom one that I built. And now I want to show you within the next few minutes how it looks. So first of all, let's take a look a little bit at the code. Let's make it a little bit bigger here. Actually, let's take a look at this from the GitHub website. It will be easier to show the repo. So this is the repo. Everyone can access it. It's a very simple Python application. these are the very simple requirements: a fast API application. This is database of the movies that we'll use, and the main code is here. Very simple code. We have 4 different endpoints. One will give you the number of movies in database with a very select count store from movies, and you can already see that here in the second endpoint there's some possible SQL injection. So you have the list of the movies. You can access some specific movies, and you can also access the stores from a specific movie. I will show you that in practice how it actually works. This is the it's actually running using UVcorn here. I just started the application locally, and let me just do a quick demo of it. So this is how you get the list of all the different movies. If I want to search for a specific movies, I can also do that. Let's actually let's search, for example, for Titanic. Okay, and then I can access a specific movie. All right, to check the stars of it. It's not movies, it's movie actually. Okay, and I can see the stars that are acting in this movie. Okay, that's very, very basic application, and there's a lot of vulnerabilities in this application. This is one, for example, a SQL injection, but there's a lot of them. And so now I want to show you how the GitHub Actions is built in, because this is where all the magic happens. So first of all, I added a job for the SAST tool, and I'm leveraging GitHub Action that is already available, and public one that is wrapping Bandit. And so with a very minimal configuration here, I'm only saying that I want the results in some output.json that I can afterwards upload as an artifact. I have integrated a SAST tool, and I will check for every PR. The next thing I want to add here is secret scanner. I'm using here GitLeaks, which also provides some public GitHub actions. So I'm leveraging this action directly, and you'll see how it works in a few seconds. For Zap, for the DAST part, what I'm doing is that I built myself the image based on the Docker file that is into the repo, and then I'm leveraging the ability from GitHub Actions to provide services. So I'm loading this image here as a service, and I'm adding here a health check to make sure that the container is actually on, is actually up and running. And then I'm using the fact that Fast API is providing me with a built-in Swagger file. So this is what I'm using here. And thanks to that, I can call Zap right away in order to crawl the different endpoints. For the infrastructure, I'm using Kix, which also provides some GitHub Actions. And so I'm, at the end, just want here to display the results in the log. And for SCA, I'm using the dependency check action that is also provided, configuring it so that it will only fail for CVSS that are 7 or more, and enabling experimental support because the application is written in Python. And at the end, I'm uploading the artifact as in GitHub as well. For the containers, I'm using Trivi. I'm here checking the code. I'm building the container using this the specific SHA of the latest commit. And I'm using the Trivi action in order to check this the base image of this container and make sure that I don't have any vulnerability. And at the end, these are the few lines of code that I added to check for the for MFA enforcement and whether or not I have users that don't have MFA in my organization. So these are the different type of tools that I integrated here. And let's see how it looks. So this is a simple PR that I created. And as you can see, everything is failing because it's a highly vulnerable application that I wrote. For each of them, I can check the results. As you can see here, for the SAST, it's actually written an output, so I can download the artifact and check for the results. Let's do that. So if I'm going into the actions, I can see the artifact here at the end. Let's scroll down. These are the different artifacts that are uploaded. As you can see here, I'm already seeing that I have a token by GitLeaks. Here I can check the scan of Bandit. Let's open the file to see that very quickly. Okay, so this is the type of results that I'm getting. Let's open the file here. Okay, so there's some vulnerability here in this file. And as you can see, I'm also getting a lot of annotations here from Kix about issues in my Terraform file. All the different controls here are providing output in different formats, but everything here is working. For example, let's see here, Trivi is providing also the results into the log. So there are a lot of different informations here. The only problem is that it's not really tied into one different control, one unified format. And so it's kind of hard to consume as is. But basically, everything here is working, and I could enter each one of them, and I will let you do that at home in order to make sure that all the different controls here are working. So this was merely an example to show you how it's easy to integrate those different tools. But as you could see, it's kind of hard to consume all the different results because everyone uses a different format. So just to recap a little bit what we saw here, we have a minimum viable security plan, and we can differentiate the different layers of the plan based on the area that you want to check. So for your code, you have your vulnerabilities, your secret. You want to add some logging and check your vulnerabilities in your libraries. For your infra, make sure that you use some tool to check for misconfiguration and that you're ensuring that your remote access is also protected with least privilege. For your runtime, do some pen testing and API security. For your pipeline, checking also that you're using some least privilege access. Data, you want to make sure that you're encrypting all your data and storage at rest. For your third party, ensure that you have MFA and you're also securing the access with all your different third parties. We didn't talk about it, but your people is also something that is really important, not only technology. And for that, you can use password manager. And for your operation, make sure you have audit and backup. Just a word about what we're doing at JIT, because we actually have taken this experience to the next level. You can customize your minimum viable security plan by adding more items in the requirements, and we also unified all the different controls, and everything appears in as comments in your PR, so that you don't have all the different formats. Everything is unified and available for as a security review in your PR. But as you can imagine, this is only the beginning of the journey, because we here only thought and only demonstrated how to deal with your most critical controls. So we're talking about MVS, and MVS is not the end of the journey, it's only the beginning. And of course, you can add next step, but this is something that I will probably talk in one of my upcoming talks in the future. Thank you very much for your attention. I know if we have time for question or in the chat, but I'd be happy if you want to interact with me. You can check our free beta at g.io, and I'd be happy to answer any question by email if you want to ping me. Thank you very much for your attention, everyone, and see you soon.
Awesome. Thank you very much, David. Are there any questions for David? If so, we'll try and do it by mic. Anyone? Any questions? No? Oh, sorry, there was a question there. One moment.
Thank you for your presentation. It was very informative. Do you have any advice for teams or larger companies with multiple teams working with various different stacks? So, and also possibly say like mobile, you got different services with different persistence mechanisms, different languages.
So yes, actually, what I presented here is what we call the MVS, and you can apply for one specific stack. But basically, the type of tools that I presented, they're most of them, and especially the one that are tied to the code, are language specific, but they're existing in many other languages. I merely here demonstrated an example in Python, but you can find the same type of tools and the same principles for a lot of different stacks. So I believe, yes, you can just expand this example and apply that to different stack and different type of technologies.
Thank you. Any other questions? Oh, one more.
So in your MVS, you use a number of open source tools. So I was wondering, in your experience, do the commercial tools, are they much better? Or, yeah, what's your opinion on that?
So I think that what I experienced in terms of difference between the open source tools and the commercial tools are usually the commercial tools are a little bit better at prioritizing the vulnerabilities and the results. And one major difference, I think, is that most of the open source tools are not really helping you with fixing the issues. Some of them are providing some hints, some guidelines, but most of them are kind of limited in terms of how they can help you with fixing your issues. So, for example, if I'm taking the example of kicks, it gives some guidelines regarding how to fix by sending you to the documentation of, let's say, Terraform. Checkoff, which is another open source tool, is doing kind of the same. But if you're taking a company like Bridge Crew, for example, in their product, they're opening a PR for you with the fix. So that's a major difference, I think.
Thank you very much. Last chance for any more questions. No? All right. Thank you again, David.
Thank you, everyone.